Can't see me yet, but it's Mrs. Gibson. And I wanted to show you the geoboard I was using from your eTools on your math website. I was using it to make different shapes with different numbers of sides and vertices. This one has 4 sides and 4 vertices. It's a rhombus. This one is a trapezoid. This one's a hexagon. Nope, it's an octagon. It has 8 sides. Made some triangles, a square and a rectangle, and more. If I gave you a blank geoboard, what shape would you make? Once you made those shapes, I could go around and I could ask a question, what shape is the most common? And then I could collect data in order to figure out whether it was a rhombus or a square or some other type of shape. Today, mathematicians, I want to teach you that we ask questions that have more than one answer, and we answer those questions by collecting data. So just as we were talking about with our geoboards, I could have everyone make a shape and then I would ask what shapes were the most common on the geoboards. Were they rhombuses, fat or skinny, that looked like this? Were they squares? Or were they one of these other shapes? And then I would take a look at all of the different shapes on your geoboard and I might think, well, one student did a rhombus, another did a square, another did maybe a rectangle, and I keep going, collecting the data, what each student tried as a shape. And then, when I'm all finished, I can think of the most common or the others, probably because there's so many different types. I might think, well, 4 did squares and 2 made rhombuses, so more did squares than rhombuses. But I also might think of how many more? Well, 2, 3, 4. 2 more. Or I could say how many kids made the shapes on their geoboards all together. 2, 3, 4, 5, 6. 6 plus 5 is 11, 12. I could do all different ways, couldn't I? But I start with a question that has more than one answer and can be solved by collecting data. So let's look at that again. That's what we're working on today because sometimes we solve with addition and subtraction and sometimes we solve by collecting data. If I wanted to answer this question, for example, what's the most common number to roll with dice? Would there be more than one answer? Yeah, because each dice has 6 different numbers on it. So I could roll at least 6 different ones if I used one die, but what if I used 2? And then every time I rolled them, I could make a tally on what I rolled. Did I roll 2 or maybe 11 or 5? There'd be a lot of information there. That would work for collecting data. What about this question? What are my classmates' favorite sports? Does that got more than one answer? I bet it does. And how about, could we go and ask students, what's your favorite sport? And then record that data with tally marks? We sure could. Would we want to do every sport? We could. What if we wanted to know football or soccer? Could we just do 2? We could, but what if we said, what's your favorite sport? And no one said football or soccer? Then what would we do? I know. We could take and we could record our information so that instead of it saying rhombus and square and other, it would say, what's your favorite sport? And we would write football, soccer, or other. Did you think of that? It would work. How about this one? How many students are in our class? That's a question. Does it have more than one answer? No. There's just 20 students in one class, and that's the answer. You can't really get more than one answer for that. This kind of question, we count up or we might find a way to tally, but it's not the kind of question for us to collect a lot of data on. I'll put that one aside. How about this question? What are the lunch choices today? Is there more than one answer? At our school, there's hot lunch 1 and hot lunch 2. Or bring your own. Could we collect data and tally it up? Maybe on this chart, it might say, what are the lunch choices today? And we would put lunch choice 1, lunch choice 2, brought from home. And then we could ask each student and put tallies and compare them. So many different choices. When we work on that, we want to make sure that we ask a question that becomes the title or the main idea of our questions. What is the favorite type of candy? That was what I was kind of thinking about. And then I thought about non-chocolates like Skittles or Swedish Fish or Sour Patch. Or would the favorites be chocolates like Snickers and M&Ms and Reese Cups? Or maybe it could be other, because maybe someone doesn't like candy at all and they don't even have a favorite. Then I could go and ask different students and collect my data. What's your favorite? And they would tell me, and I would record where they were on my chart. And then finally, mathematicians, I'm starting to see the math. I could say, what was the favorite? That's the one with the most, non-chocolate. How many more non-chocolates than chocolate? Compare, so I need to subtract. 5 minus 4 is 1. I could ask, how many students did I ask in all? 5, 6, 7, 8, 9, 10, 11. What other questions are you thinking that you could ask that we could solve with these tallies? So much math when we ask questions that have more than one answer, and we answer that by collecting data. So today, mathematicians, you're going to think of a question that has more than one answer, and then collect the data by putting it on a sheet like this. Don't forget your question, your labels, and your tallies. Okay, can't wait to see the results. Off you go.